guys, Henry from Adventure Air here, and today we have a special treat. We have Jimmy from Jimmy's Wild Adventures, and he is a super gyro instructor, and we're happy to have him here with us in Chino, and he's going to talk to us today about rotor balancing. We're just going to briefly talk about a little bit about an introduction to rotor balancing and what he looks for, because he is the rotor balancing god. So thanks for being here, Jimmy.
Thanks for having me. And yeah, we'll go through all the steps. I like to say it's kind of like paint. 80 to 90% is prep. That last little 10 to 20% is actual rotor balance. So we're actually going to start out not at the rotor, but all the other things that lead up to getting a good rotor balance. No stick shake, no body shake, and a smooth ride.
Cool. All right, let's go do it.
Let's do it.
Woo!
Now watch, we're going to go up there and be like zero stick shake. And we're like, all right.
We didn't clean the blades or anything, so we should be all right with that. Die. Cool. Come back to life. 3,
Come back
2,
to life.
1. Lane B. Die. Good there. Come back to life. 3, 2, 1. Good cadence. I've done this only once.
Yeah. Hey guys, so we're going to take a little flight around the pattern here and kind of see what's going on with the stick shake on this guy. And so let's go have some fun. Woo!
All right, 200 on the rotor. Step 1, let go of the button. Step 2, stick goes back. Step 3, let go of the brakes. 4 at power.
Information that's recurring wind 2609 is us 15 altimeter 29902.
All right, now we can feel that yaw kind of happening. Give it a little bit of right rudder, a little bit of left stick. There's the float. And we're in a wheel balance and a perfect takeoff. Add some trim pressure, lower the nose, build some airspace.
And 715 Bravo, Chino Tower information that's current wind 2609, gust 15 altimeter 29902, right traffic, runway 26 right.
All right, so let's check this stick shake out. See what we got here.
2 Papa Golf, new beginner, early right cross on.
Sure. 2 Papa Golf.
2 Papa Golf, thanks traffic crossing midfield, runway 26 right, clear for the option.
Clear for the option, 26 right. 2 Papa Golf. Almost hit my tail.
No.
All right, so we're going to reduce some power here. Get a nice trim
Go
going.
ahead and start your crosswind, though.
So in a turn, the blades are loaded, but they're not tracking the same air. In a vertical descent climb, they're not tracking the same air. When we get straight and level here, low power setting, we're going to try to assess with about 420 rotor RPMs where we are. And then we'll get a good assessment. We've got a forward and back shake, which indicates, since the gyroscopic recession is 90 degrees off, that there is something with the cord. The cord is adjusted with those chims or straightening the blade. So we're going to check the fork and the teeter hub itself, the teeter tower, to make sure that there is no looseness in there. Everything's nice and tight, and the blades are straight. That will give you the forward-back stuff. And I kind of got a little diagonal, not much. But the fact that I can hold the sticks, still feel it pulsing, it's minimized, means that the PPC cables are a little loose. Now the overall cab body shake, it's there. It's not too predominant, about 70 miles an hour, 420, 30 RPMs. We got this. So when we come in on a final, we're going to do a vertical descent with and without power to see if that stick shake is reduced, which would indicate a prop imbalance. Cool. So we're already cleared for the option, and we're turning base to final on 26 right. Cleared our turn.
2 Papa Golf, runway 26 right, clear for the option.
Clear for the option, 26 right, 2 Papa Golf.
Number 2 Papa Golf, turn base when able.
On base to final, 26 right, 2 Papa Golf.
Number 15 Bravo, I'll call your base turn. Your number 2 following the Gyrocopter, short final.
Number 2 follow the Gyrocopter, wait for you. Thank you, sir. 15 Bravo.
All right, cool. We're going to reduce power to idle. We're going to stay up here nice and vertical, and we're going to notice the stick shake and the RPMs. All right, there's our speed. We got a little bit of a headwind. Rotor, we want to get it back to around 420s. Look at the stick shake, very minimal. Almost no rotor authority. Now we're going in a vertical. We're going to add some power. We're going to see what it does to the shake. See how the shake's increasing slightly? That would indicate a propeller imbalance as well.
Chino Tower 340, Mike, go ahead.
420, low power.
Right, we're ready for VFR departure.
More power.
Downwind.
See the stick shake increase with power? It's also loading the blades, but that could actually be all in the propeller. A lot of it.
Air 340, Mike Juliet, Chino Tower, standby, chart short final.
And we'll land over there by Delta, so we can just go home.
0 Mike Juliet, cross runway 26 right, taxi Papa.
Oh, he's having the guy use
Okay, Sir Mike Juliet, I'll cross 26 right and taxi 26 left at Papa.
We're skirting a little. That's all right. We're gonna bring her on down.
Turn 15 Bravo, base turn approved, runway 26 right, clear line.
Bravo, clear line 26 right.
Combination of brake and stick. You like that?
Tower 827 wind 7 to the west, full stop X-ray.
Yeah. I do believe a lot of it has to do with the propeller too.
Okay.
They saw in the vertical, it was almost nothing.
Yeah.
So vertical, no power, add power, shake, it's engine something. But then vertical, engine power, no shake, we start moving forward, blade tracking. But in flight, that little bit we're getting would, I would think, go straight to the rotor head. And that's a good point. I would say, yep, based off my experience, it's got a chord imbalance. It could just be the propeller. All right, cool. So we just went and flew it, and you guys saw how we went around the pattern, steady 70 miles an hour, about 420 rotor RPMs. We had a stick shake a little bit left and right. And that would make me start to think, okay, the rotor chord needs to be adjusted, but then we went into a vertical on final with and without power. Without power, it was a pretty smooth stick. And then when we added power, we got stick shake. We checked it a second time, we got stick shake. So the first place we're gonna start is actually the propeller balance. So overall, the whole way we're gonna do this, methodology, if you will, we're gonna start from the bottom up. So we've already checked where the balance is now. We're gonna look at the propeller and see where that is. For an example, if you have a rotor head up here doing its thing, and you've got somebody behind you kicking you the whole time, what's your head gonna be doing? Sometimes it's not in the rotor, it's other parts. So we'll check that first. Stay tuned. All right, cool. So right now today we're gonna be using the Prop Balancer 4 by Smart Avionics. It's awesome. You can balance your propeller and your rotor with it. We're only gonna be using a single XY axis accelerometer on there. They also have an optional Z for the height, the hopping. But people have been doing it like this for years. It works. I'm not trying to add complication to it, so I'm gonna continue with what works. And then we got an RPM sensor, so it can track exactly where it is. The way they measure it is basically with a bullseye. So the center of the bullseye, and then each time the propeller or the rotor rotates, it will take a recording of that, and it's recorded in inches per second outside of the center of the bullseye. What we want is 0. So we want 0 inches per second revolution. So right now, we're gonna set up the machine and see where it's at, and then we'll go from there. So the goal, as you guys can see, there's an X and a Y axis. They point in those directions. The theory is we want to have that intersecting with the center of the propeller. The best way to do it is to mount it somewhere on the propeller flange, not the flange, the back of the gearbox. So you can see that arrow pointing downwards. If we angle it 45 degrees, it'll intersect with the middle of the gearbox. And that way we can get a true recording how out of balance it is. And with the propeller balancer, you're only using one of the axes, X or Y. With the rotor, we'll use both. So, looking at this configuration, we're just gonna simply clamp it on there, angle it so it intersects, and take our recordings.
So we're just securing the clamp. Keep things from rattling.
Just in case it wants to come off, won't go through the propeller. Cool. That's solid.
Yeah, I'm showing you to the sensor here. We put the sensor on. It's got the red light on it.
RPMs. One more.
Shining back at the prop.
All right, so we've got a piece of reflective tape, exactly 25 millimeters, about 1 inch wide. We're gonna be using on the back of the propeller, and that's what the RPM sensor uses to see as the propeller is spinning. Now, where to place it? As you guys can see, red blinking light right there. It's gonna be solid or blinking. So we got a solid light right now, blinking because it can't see its own reflection. So we get a piece of reflective tape that the sensor can then see it stays solid. Can't see it reflecting off my hand. Give it a few seconds, it'll start to blink. Now it doesn't see itself, and now it does. Pretty simple. So we just chase that red light over the propeller, make sure it's solid. Nope. Okay. Try to find a good spot for it. What are you doing? What are you doing? Come on.
We can come up on it a little bit. Yeah. Yep, right there.
Cool. That's it. Solid light. We're going to put it right there. Cool. All right. So we got the software loaded up. Obviously, there's no vibration, so it shows perfect balance. It's in the center of the bullseye. We're going to run the engine now, idle, let it warm up a little bit. And then we're going to rev up the engine and check balance at different RPM settings. And find one that we use closest to cruise, balance it for that. All right. Do this stuff. Lights. All right, clear? All right, so now we got a unit of measure. It was 0.4 of an inch per second off balance at cruise, which means every single time this spins around, it's moving in space almost half of an inch per second. So that's definitely going to throw the balance off on the rest of the machine. In order to get it properly balanced, we first have to put some sort of unit of measure somewhere in the circle and then run the machine up and tell it, we did this change and here's how it influenced the balance. Now, if you look at the way this is configured, we've got 8 different possible spots we can put weights on the cone itself without having to go too in depth on the inside. With Rotax, it's a light engine, you don't have to put huge weights on there. So all we're gonna do is simply add a little 4mm metal washer to one of the sites that mounts the cone onto the prop and tell the machine we made that change and repeat it 8 total times. And then the machine will tell us, based off of that, here's what you should do. All right, let's do it. All right. Flip this. Good for the run-up.
All right, so we moved the weight from position 1 to position 2, right there. And now we're going to run it again. Okay, now we moved it from position 2, the weight, to position 3, and we're going to run it up again. Okay, so after we put the weight at all 8 locations, we did the run, and it said that we needed 1.5 units of measure, which is one of those washers, on area 7, and 1/2 of one on washer 6. So we put those on, and we're going to see if it works now. All right, so what we did was we turned the ship around because we're having a wind come from out of the west, and we think that was affecting the prop by blowing. So you have to have the wind coming from your nose on these tests, and also not from the side. So you need a headwind only, or otherwise it'll throw off the calibration. All right, so Jimmy, tell them what happened there.
All right, so we started out with an average of 0.34 inches per second each revolution out in space, wobbling, and through a handful of carefully placed weights, we measured different points to see what we could do to get it the best, closest to center. 0 inches per second is the goal. My personal goal is 0.10, so 1/10 of an inch per second and below. We averaged here 0.12, so 2/100ths of an inch off is a 70% improvement from where we began. So, or at least that's what the machine says. That sounds about right. Quick public math. But as you can see, all the multiple points, that bullseye is where we want it. We got to zoom way in to get it. It's just barely off, and that could be factors such as the wind, dirty blades, one of the blades slightly out of track. But where we started, way over here. Where we ended up, very, very close to the center. So we're gonna go fly and see how she performs.
Woo! Woo! Tiny bit of forward back, huh?
Yeah. Still there. But we did take the...
Yeah, a lot of it's out though.
If we tighten up the clamps as well, it's kind of what this motion will mimic.
Yeah.
Intel 12, taxi Delta Mike, good night.
So in this turn, I'm going to bank a little more than a standard rate.
Sounds good.
Could see RPM change, so at 450 it's pretty smooth.
Yep.
So we're going to
Archer 79 Mike
go a
here,
little faster.
on the localizer, 26 right, low approach.
Check, 7 North here, Chintar, continue.
Continue, 9 Mike here.
2 Pop Golf, run 26 right, clear for the option traffic on a 5-mile final Cherokee.
Clear for the option 26 right, and we'll be looking for 5-mile final. Thank you, 2 Pop Golf.
Cherokee 9 Mike, number 2, followed Gyrocopter on the right downwind 26 right for low approach.
116 ground speed.
Low approach.
Cherokee
Alright, we're at 440 RPM.
10 miles ahead, run 26 right for low approach.
Number 3, for low approach, ILS to the vehicle.
Front and back, I'd say it's worth looking at the rotor.
777, behind the King Air, run 26 right, taxi Mike Delta Alpha.
That's a little out of balance because we've got the rest of it smoothed out.
Yeah.
Even with that doing that, the cab's not that bad.
Yeah.
Cruising 131 miles an hour.
Request west cross
Okay, we're gonna go ahead and turn in. We got somebody on a 5-mile final.
Did you roll the roll trim over, or did it do it by itself?
I've been doing it
That's
Oh, you've
the
been
whole
doing
time.
Okay.
Stand by.
I'm gonna try to do a vertical, but we got a guy on a final.
Okay.
So maybe we'll just do a low approach so we can do it again.
Yep.
I think Mike's just going to do a low approach, or 2 Papa Golf's going to do a low approach.
5 Tango Mike.
Golf, Roger, the Cherokee's still on a 3.5 mile final if you want to get to your touch and go, but that's fine as well.
Okay, thank you, 2 Papa Golf.
I said my tail number. So if we pick up speed and it increases, it's more like a blade tracking.
3. Okay, lifting final cap for 202.
Lima Charlie, contact my frequency 118.5 tower frequency.
Right there.
CFI 302 remain.
Not much of anything at all right there.
Aircraft inbound.
202,
This is Zulu Hotel, cross runway 26 right at taxiway Papa.
So,
26 right at Papa,
same 70,
2 Delta
same
Echo,
rotors,
reduce speed 10 knots again.
just propeller.
Center Mike Sierra, increase
You can
speed
see
again,
how much of a difference it had
It's got a 30 knot overtake.
from when we first flew.
Airspeed, Mike.
Yeah.
102 Lima Charlie, are you on tower frequency?
Yeah.
That's not
Much
far
better.
off. It is. That was just
2 Lima
propeller
Charlie, cross
and
runway
control.
26 right
Yeah.
at taxiway Papa and hold
Cool.
short of runway 26
Again.
left at taxiway Papa.
It's a fine art. It's a balance, but you have to start from the bottom up. So far, we spent the entire afternoon doing just the propeller stuff. Just propeller, getting that part right.
Switch it back to our...
I try a little climb,
Right,
same
that's
speed.
Zulu Hotel, make left close traffic, runway 26 left. Correction, Zulu Hotel, left crossing approved, runway 26 left, taxi Pop, left takeoff.
I'm trying to see if it's airspeed, RPMs are staying, the downwind's happening.
Chino Tower, Archer 79 Mike Sierra is going there.
9 Mike Sierra, Roger, continue runway heading.
Gonna stay inside of this
Continue runway
helicopter.
heading, 79 Mike Sierra.
That's gonna be him. Okay, and bringing back the power. About 44.
CAPR 302, you can proceed on course, frequency change approved, good day.
202, thanks, we'll talk to you soon.
So
That's fine. You know.
I'll say this is great for student flying
Yeah.
when you're not trying to push it.
2 Delta Echo, continue runway heading.
Runway heading to Delta Echo.
To Delta Echo, can you verify our left turn?
2 Delta Echo, continue runway heading, fly runway heading.
Fly runway heading to Delta
All right.
Echo.
I'm happy with all that.
Chino Tower 79 Mike Sierra have the...
Yeah, better.
9 Mike Sierra, left turn approved. Again,
And that could be the
that's
gimbals
Palomar there with SoCal now, left turn
that
approved.
need tightening. With this many hours on it,
Yeah.
guaranteed they're worn.
79 Mike Sierra.
And
Turn approved, 79
so we haven't balanced. We still haven't balanced the rotor. I think that's what I'm trying to prove in this whole thing, is that it's not a rotor balance. It's everything else. Because when you tell me it was once flying perfect, now it's got stick shake. Well, guess what? How did your rotor get out of balance? Did you lose part of it? Did your rotor become loose? No, but there are wear items that need to be inspected periodically.
7 Chino Tower, Roger, cross runway 26 right at taxiway Papa, traffic mile fun.
So now if you balance your rotor to get rid of the vibration the best you can, but you didn't remove the causing problem, the whole cause for why it's shaking, you're only amplifying. You're putting a band-aid on a
102
problem.
Lima Charlie,
The problem's
Lima
just going to
Charlie,
develop.
start your left crosswind turn.
So
2 Delta Echo, traffic 11 o'clock and 1 miles on a cross.
that being said,
left pattern.
like this, 70 knots, student flight,
Yeah, it's pretty nice.
just for that little bit.
Roger, I'll call your left turn.
Roger, to Delta Echo.
477, fly runway heading, runway 26 left at taxiway Papa, clear for takeoff.
Now with no power,
2
so
Delta
motor
Echo,
mount
left turn
stuff,
approved, and
too.
contact SoCal departure.
Left turn approved, contact SoCal to Delta Echo.
and adding power, we're doing 70. We must have a pretty good headwind.
Yeah.
Our ground speed, oh, it'll catch up, but we got to be doing like 30.
Piper 2 Lima Charlie, runway 26 left, clear for the option.
206 left, clear for option 2 north.
I mean, that's about what we were cruising at, slightly lower. Boop.
Yeah, much better, much better.
I think PPCs could even be tightened more. I just tightened them till they were snug. I didn't actually pinch anything down.
Yep.
But I went like 3-4 turns with finger pressure.
Right.
Until they just got snug, and that made a difference, I believe, as well. That can't hurt, because with and without throttle, I didn't really see much of a difference. It was pretty consistent. Before we would go to idle, add the power, and watch it go.
Yeah.
Except when we really loaded it, really started hauling ass. I felt that a little in the cab.
Thank you, Jimmy.
Yeah.
This is definitely much better. And we'll give our viewers something to look and think about, you know, of the procedures for getting all stick shake out. You know, just like you said, start from the bottom up. And you got to definitely balance the prop before you try balancing the rotor.
Yep, so we've been improving. This, call this part 1.
Yep, we'll call it part 1.
Part 1 to the series.
To be continued.
Definitely. Just to improve from what we did this morning to this afternoon, and we have not touched the rotor or tried to attempt to balance the rotor yet.
More tricks to come.